Okay, so now we're going to do a factoring lecture, particularly factoring trinomials. Factoring is a very basic and important foundation to have when proceeding in mathematics, especially in algebra. And algebra is an important foundation to have if you're going to proceed into any higher level course such as calculus or differential equations or trigonometry. So we should have already watched our seen the factoring trinomials handout, and now we're going to use that same method, factoring by grouping, to factor various trinomials, and we're going to go a little bit quicker than we did in that video lecture. So there's just some basic formulas to be aware of. I don't really focus on them too much because if you can factor by grouping, then you can basically figure all of this out on your own. There's the difference of squares, and it has a formula, and there's perfect square trinomial formulas. But let's just get into the factoring linear expressions, or factor into linear expressions. We're going to factor trinomials. These are all quadratic expressions currently. So on this one, I'm going to draw my t-square. I usually do it to the left-hand side. You could do it wherever you want. 2 times negative 3 is negative 6, and we want factors of that add up to 1. This will feel very familiar because it's the same example we did in our other lecture. We know we need factors of 2 and 3, and the 3 has to be negative in order to add up. I'm going to rewrite my factors out of order just to show the variety that, it does not matter what order you write them in. In the previous video, I did it in the reverse order, but I want to illustrate that it really doesn't matter the order in which you write these two. These two factors have to add up to be your middle term, and they do. So we're okay there. We haven't done anything illegal to the problem. It's still the same problem. It just looks a little bit different. Draw parentheses around the first two things and the last two things. Take out what you can from the first set. I can just take out an x, and I'd have it 2x minus 3. Here I can take out, it looks like nothing. When it looks like you can't take out anything at all, take out a positive 1, and you'd have 2x minus 3. If the inside pieces are the same, in which they are, you drop them down and write them one time, and you connect your outside pieces with their own set of parentheses. So we have the exact same answer that we did in the previous lecture. But like I said, we wrote the order of the factors we used in a different order, and that doesn't affect anything. Alright, so let's do one that we haven't done before, which is this guy. We're going to take 3 times negative 8, which is negative 24, and we want factors of that add up to be 10. How about, I want to say 6 and 4, but that's not going to work. How about 12 and 2? If the 2 is negative, they'll multiply to be negative, but they'll add to be that positive 10. So let's rewrite the expression using the two factors. Again, the order of them doesn't really matter. So we replace the middle term with the two new factors that we found. Don't forget your x's. Draw parentheses around the first two things and the last two things, and technically there's a plus sign right here, but often I'll leave that off because I know what I'm doing. Let's take out a 3x from the first set. We'd have an x plus 4 left. Second set, let's take out a negative 2. We'd have an x plus 4 left. Inside pieces, inside parenthesis pieces are the same. We want that. We drop it down, we write it once. We connect our outside pieces. And we're done. The next one does not have a number in front of x squared. When that happens, you can take a shortcut and just write parentheses, and this is what my college algebra teacher would always do. You just write parentheses and then magically fill them in. How the magic filling in goes is you do the same thing. You want factors of the first coefficient times the last coefficient that add up to be the middle coefficient, signs and all. And here we're going to use 5 and 5 because 5 plus 5 is 10, 5 times 5 is 25. Both of these need to be positive, and the shortcut is when there's not a number in front of x, you can just put x and then your factor. So x plus 5 and then x plus 5 in parentheses. Now if we had factored by grouping, we would have got to the same exact answer. Okay, so that's the shortcut method, and as we go on I'll use the shortcut a lot, but factoring by grouping can get you there the same. This one does have a number in front of x squared, so I'm going to factor by grouping because I don't like to think much. 2 times negative 3, negative 6, 5. Here's where I think I have to think, well, what are factors of negative 6 that add up to be 5? How about 6 and 1, where the 1 is negative? That's all the thinking that I really do in this process. That's why I like this process a lot, because I don't have to use my brain that much. The rest is just autopilot. Rewrite the expression using the 2 factors, draw parentheses around the first 2 things, and the last 2 things. Take out what you can from the first set. You could take out a 2x, you have an x plus 3, and then take out a negative 1 from the next set, you'd have an x plus 3. Inside pieces are the same. Drop them down, write them once. Connect your outside pieces. 2x minus 1 times x plus 3, and you're done. Okay, on this one, it's not a trinomial, it's a binomial, so you can't use factoring by grouping, so just take out what you can. We can take out an x, and we'd have a 3x minus 7. And we're done because it says factor into linear factors. X by itself is linear. If you were to graph that, it would make a straight line. 3x minus 7 is linear. If you were to graph just this piece by itself, it would make a straight line. Linear means straight line. And that is the first page of the factoring lecture. We're going to go on to the second page in the next video.